Okay guys, listening, if you get any answers that's different from mine, make sure you discuss it with me, because as you know, I could have made some mistakes. Okay, so question 1 from graphs and relations, part A: how many kilograms of phosphorus are in 2 kilograms of boosters? All you have to do is to look up the table that's given above. So phosphorus, for every kilograms of booster, that's 0.02 kilograms of phosphorus. So 0.02 times 2, 0.04. Part B: if 100 kilograms of booster and 400 kilograms of fast grow are mixed, how many kilograms of nitrogen would be in the mixture? Assuming that all the other chemical ingredients within the two packages are not going to interact. Okay, then you have got 0.05 kilograms of nitrogen per kilograms of booster, so 0.05 times 100, and 0.05 times 400 kilograms of fast grow. So when you multiply anything with two zeros at the end, you shift the decimal point twice. 5 times 1 is 5, 5 times 4 is 20, so the answer is 25. Or use your calculator. Part C. You need to read the question carefully. Inequality 5 represents the potassium requirements of Arthur's tomato field. Potassium. Write down inequality 5 in terms of x and y. X and y are defined here. X is booster, y is fast grow. The information for potassium is given here. Okay, so 0.06 kilograms of potassium for every kilograms of booster, so 0.06 times x, and 0.04 times y must be at least 180 kilograms, so it's greater than or equals to 180. Now, before I continue to the next page, I would like to draw your attention to the coordinates here and here. Okay, so there's no secret to it. All I did was I substituted x equals to 0 into inequality 3. When I do that, then the y solution would equals to 4,000. Okay, so and then vice versa, if I substitute 0 into y for inequality 3, then the x solution would come out to be 4,000. You can use your CAS calculator to do this and repeat the same process for inequality 4 and then inequality 5. Okay, you don't super have to do this, but the reason why I do this may be, well, definitely will become obvious on the next slide. This page will take a while to explain, so please focus and listen carefully. Okay, part D1. Using the graph above, write down the equation of line A. Now there are two ways of doing this question. Okay, the first one is you start with y equals to mx plus c. M is equals to rise over run, so it's minus 2,000 divided by 6,000, and therefore the gradient is minus 1 over 3 if you simplify that equation. Then the y-intercept is at 2,000, as you can see. Whoops. At 2,000. So y would equals to minus 1 over 3x plus 2,000. Or, if you have seen on the previous page, I've substituted x equals to 0 and y equals to 0 into each of the equations from 3 to 5. Okay, if I've done that, then those coordinates will tell you which line is which formula from the previous page. So in this particular case, line A is 0.02x plus 0.06y equals to 120. D2. On the graph above, shade the region that satisfies inequalities 1 to 5. Now, you can either enter all the inequalities into your calculator and copy down the shaded area, or you can do the substitute 1 point into the equations strategy, okay? In this particular case, the easiest point to pick would be 0, 0, the origin. Now, if you pick that point and substitute 0 for x and 0 for y into each of the inequalities, you would know that it'll fail all the inequality tests for 3 to 5, because obviously 0 must be less than all the values given to you, so that is not in the feasible region. Therefore, the feasible region must be above all the graphs in the areas I've shaded here. Okay, now let's move on to part E. This is about objective function now, okay? So let's read the question. Arthur would like to use the least amount of his own fertilizer to meet the nutrient requirements of his tomato field and still satisfy inequalities 1 to 5. He will therefore minimize the total weight of fertilizer W, where W is equals to x plus y. The sliding line method is to be used to determine the weight of booster and fast growth fertilizers he will use. Now, E1. Write down the gradient of the objective function W is equals to x plus y. The gradient. The easiest way to figure out the gradient is to rearrange the function into y equals to mx plus c form. You can use the CAS calculator to do it, or you can use algebra. Y is equals to minus x plus w. When it's minus x with no number in front of the x, it implies that it's a 1. Okay, so minus x, the gradient is minus 1. E2. On the graph above, draw the line that passes through the point 0, 1000 using the gradient from part E1. Okay, now, in order to draw a linear graph, you need a minimum of 2 coordinates. In the question, you've already been given 1, so now we have to find the second coordinate. In order to find the second coordinate, the first thing we have to do is to substitute 0, 1000 into w is equals to x plus y, or y is equals to minus x plus w. Okay, so 1000 is equals to minus 0 plus w. W must be equals to 1000. Then you can rearrange, or you can start your finding of the second coordinate using y is equals to minus x plus 1000, or 1000 is equals to x plus y. The easiest way to do it is to substitute y is equals to 0, because then immediately you can see that x must be equals to 1000. So the line is here. Now, finally, E3. Hence, show on the graph above the points where the solution for minimum weight occurs. So, we are going to use the sliding line method to determine the weight, right? However, I'm not quite sure how we can show the sliding line method without videoing it. So I'm going to do a separate video of how to do it, just to refresh your memory. But in this particular question, you shouldn't have to use 2 rulers or any other fancy way, because 1000 and 1000, right? Which means that when you've got another line going through 2000 and 2000, it will be parallel. 3000 and 3000, it will also be parallel, and 4000 and 4000 will also be parallel, okay? Which means that the solution for minimum weight occurs happened on the line x plus y is equals to 4,000 for x is between 1,000 and 3,000, where I've kind of like used black because I'm lazy to change my pen color and make it super thick here. Okay, now you want to be careful because this is part of your feasible region, right? So I'm going to change my line color to red again. Now this bit of the line and this bit of the line, they are not part of your minimum weight solution, okay? If you don't believe me, you can substitute any of the coordinates on those lines into the x plus y equals to 4,000. You can see that when you substitute any points there, you will not get 4,000, which means that it's no longer the minimum, okay? Have a think about it. If you are still not sure, see me after class and we'll talk about it in more details, okay?